everyone, and welcome to lesson 1.3, part 2. Today we are going to talk about deriving and using the distance formula to find the distance of 2 points. So at first, we are going to talk about our Pythagorean theorem. We previewed this a little bit at the beginning of the school year, and what Pythagorean theorem does is it allows us to find the third side of a triangle given two of its sides. C, the hypotenuse, is the longest side. It's called, it's going to be using a C, and then the two legs of this right triangle are going to be using A and B. So when we're using Pythagorean theorem to help us find the distance or the length of a segment, first thing we need to do is actually plot that segment. So we're going to draw PQ. P is at 1, 4. Q is at 13, 9. So we are going to plot those 2 points, and we're trying to figure out the distance between them, aka the length of this segment. Now what's going to happen is this is going to be our C. Okay, this is going to be the hypotenuse, and what we're going to do is we are going to draw in 2 legs to create this right triangle. Okay, and where they meet is going to be that right angle of our right triangle. And what we need to do then to find the length of those 2 legs is we are going to figure out the horizontal length. So we count from 1 to 13 on our number line here. So that's a total of 12 units. And then point P started at 4, and then point Q is at 9. So that's a total of 5 units. And count the boxes 1, 2, 3, 4, 5. And again, it doesn't matter which one is A and which one is B, but together A squared plus B squared will equal that C squared value. So again, in the calculator to do that, we have 5 squared plus 12 squared, and then we can square root that. So second x squared, we type this in so that we get 13. So 169 again was the C squared, square root to get our final answer here of 13. Again, we can do this on this next example as well. They were nice enough to plot points A and B for us. So again, this will become our hypotenuse, and then we can draw in. Now, it doesn't matter if you draw in the right triangle going down like this. You could also draw the right triangle this direction because the length of A and B will end up being the same. This time we have 1, 2, 3, 4, 5 units here. 1, 2, 3, 4, 5 units here. And again, our hypotenuse is our segment A to B. So C squared is going to equal 5 squared plus 5 squared. Look at our calculator. 5 squared plus 5 squared is 50. And we are going to need to square root that value to get our final answer this time of about 7.1. Just going to just give us the rounding if needed. Try the next example on your own. You are finding the length from R to T. Now, Pythagorean theorem has its uses, okay? But what if we are given 2 points, for instance, on this last one, that are really big, like 100, 101, and the other point is at 1,000, 462, okay? We are not going to want to have to try and graph and count and do Pythagorean theorem for that. And that's where the distance formula comes into play. What if we just want to figure out the distance between our x's, distance between our y's, and a shortcut formula we could plug into using Pythagorean theorem, but in a more user-friendly way than having to graph and having to look at those side lengths. Okay, and that's where the distance formula comes into play. We are able to use Pythagorean theorem for any 2 x, y coordinates to find that between. So again, we are able to find this now as opposed to Pythagorean theorem to help us find that. And this is, again, the distance formula where you're using your 2 given points and you will be plugging into this formula. Okay, now, something to be cautious of with the distance formula is what type of calculator that you have. Because if you're typing it in to a graphing calculator with math print and you see this on the menu, you can kind of type this in as one step if need be, because those parentheses are going to be in the same place. Again, x minus x and then y minus y squared on that. Notice though on calculators without math print, so for smaller calculators or non-graphing calculators, you're going to look something like this. So instead of when you square root going underneath, you see this parenthesis there. Now, they're not being nice to you. Okay, they're not putting this parenthesis for you. They're saying everything that comes after this parenthesis is going to be in the square root. So you would need another set of parentheses to type in so that you would know at the very end here to close this and that would all be underneath your square root. So be careful of your calculator, or we'll talk about a way that will help you make sure that you type this in correctly. Okay, so again, we are going to start off similar to the midpoint formula. We are going to start by making sure we label x's and x's, y's and y's. Okay, and what we could do is, again, we have the square root, and we're going to start with our x's. X minus x, quantity squared. And then we add that to our two y values, subtracted and added together. Again, it's always subtraction in there. Now, even though it's minus and negative. Now, when I type this in the calculator so that I do not mess up this square root, what I like to do is I like to type in the information that would be underneath the square root first, and then I type the square root after. So I'm going to take 4 minus 8 quantity squared. And then I'm also then going to add that to 7 minus negative 5. Again, close that parenthesis, quantity squared. Okay, whether you see to the caret, the squared. And underneath right now, my square root, I have 160 underneath there. Okay. Then I could take as a separate step the square root, so I make sure I don't have any parenthesis issues. I should get 12.6 as my rounded answer. Okay, again, if you were going to type this in as one step, make sure that you would take the square root and you would parentheses 4 minus a quantity squared to start this off so that you know you're going to type this in correctly. Or do it as two steps. All right, let's look at one more example before you try one on your own. This time, A and B have the points 3, negative 3, and negative 4, 4. So again, I'm going to start with my x's, 3 minus negative 4, x minus x, quantity squared. We will add that to our two y values subtracted, negative 3 minus 4, quantity squared. And I like to do this as two separate steps. I like to take my values underneath the square root before I square root. So 3 minus negative 4, quantity squared, plus negative 3 minus 4, quantity squared. And then we will square root that value of 98 for a final answer of about 9.9. This 9 makes that 8 round up. So again, that was the square root of 98, which is about 9.9. Try on your own finding the length from P to Q, given those 2 points, round to the nearest tenth if necessary. Thanks everyone for watching. We will work more with this in class.